Use the back door. Back door.
Namaskaram. Today, we have gathered here for the inaugural ceremony of two residential camps, Crystal and Science Quest. Crystal, Crafting Young Scientists of Tomorrow, is a mentoring program of Kerala Science Council for Science, Technology and Environment for school children. Every year, about 30 students who are the state level winners of National Children's Science Congress are selected and are given the opportunity to undergo training in science and technology at reputed institutions. IIT Palakkad hosted Crystal last year, and we are happy to host the program this year again. Science Quest is a residential science camp conducted by IIT Palakkad in memory of late Professor M.C. Valsakumar, former Professor of Physics and Dean Students Affairs at IIT Palakkad. Professor Valsakumar, Valsa to his friends, was an excellent researcher, an extraordinary teacher, and above all, a humanist. Studying his passion for science is our way of continuing the journey with him. IIT Palakkad selects 30 students from schools across Kerala and Coimbatore district. The goal of the camp is to instill a spirit of inquiry and critical thinking, love for science and mathematics in students. We now invite Dr. Anand TNC, Associate Professor, Department of Mechanical Engineering and Dean Academics of IIT Palakkad for the welcome address. Welcome, Dr. Anand.
Good morning, ladies and gentlemen, boys and girls. Thank you so much for being here. I'm delighted to be here on this occasion because it's always a very nice thing when we have students joining us, and young students are especially welcome here. As a student myself, I was very fascinated to look at experiments in physics and chemistry and math and so on. And I hope as part of the next 10 days or so, you will sort of get to share in that feeling of excitement which we had. We also hope that many of you will go on to continue in your desired fields in math or science or engineering or technology. And we really hope that some of you will come back and join us here, either as students in bachelor's or master's or PhD, or maybe as faculty at some other point later on, and that you'll come back and tell us that you were here so many years back on this day. So that's something which we really would like to see. As far as the program itself goes, in relation to Science Quest, I'd like to really thank Mrs. Geela Valsakumar. Madam is here. Thank you so much. I'd like to thank Mrs. Sundaraman and Professor Sundaraman also for their support. Thank you very much. We are really happy that you were able to support us in the previous years, and also we are able to have this program because of you. We, of course, remember Professor Valsa. He was really a gem of a person, and there are plenty of students who would testify to that. Many of the students he taught have passed out, but they all remember him very fondly whenever they are here. And as far as the Crystal program is concerned, we would like to thank Dr. Neetu. Thank you very much to you and to your organization for supporting us. And we hope that this is something which will continue in the years to come as well. So thank you once more for joining us. We would like to thank the parents for encouraging your children to apply for this. We'd like to thank all the kids here who decided that they would like to go through this. We hope you have a really enjoyable experience, and we hope you'll spread the word and we'll have more applicants in the future. And yes, wishing you a very good time while at IIT Palakkad. Thank you.
Thank you, Dr. Anand. We are happy to have Dr. Neetu representing Kerala State Council for Science, Technology and Environment, KSCSTE. Dr. Neetu has obtained her PhD in Environmental Engineering from Indian Institute of Technology, Kharagpur. Currently, she is a scientist in KSCSTE. Dr. Neetu manages several schemes and programs of KSCSTE aimed at promoting science and technology development. She will be staying with us at IIT Palakkad during the camp. I welcome her to the stage to tell us more about the Crystal program. Welcome, Neetu.
Thank you for the nice introduction. So, respected dignitaries, faculties of IIT Palakkad, dear parents, and my dear students. So, good morning and greetings from Kerala State Council for Science, Technology, and Environment. So, here today, I would like to give a short briefing about the program Crystal, that is Crafting Young Scientists of Tomorrow. Okay, so before that's actually science orientation program of KCST. So, before going into that, I would like to showcase some of the activities of Kerala State Council for Science, Technology and Environment. So, the program will be during 22nd to 31st May 2023, and that is it's a 10 days camp. Okay, sorry. So Kerala State Council for Science, Technology and Environment, it's an autonomous body which is under government of Kerala, and which mainly works with an objective to promote science and technology in the state. Okay, so this is the main organizational structure. You can see we are headed by the council is the main head of the council is Chief Minister of Kerala, and then comes Executive Vice President. Now we have Dr. Sudhir KP from IIT Madras. He's on deputation and he's acting as the Executive Vice President of the council. And then we have a lot of directors, we have R&D centers, and a large group of scientists who comes under the head, means the branch of KCST. So apart from some of the programs that we conduct in the headquarters, we have totally 8 R&D centers, that is research and development centers, which is spread throughout the state of Kerala. So these are the R&D centers. You can see each one works with a different objective, like the research area or research going on in each of the centers is different. I'll come to that. So apart, as I said, the main headquarters, we have certain schemes and programs which we aim to different age groups. For example, for you, you have the programs Crystal. Similarly, there are many other programs which we target the school students, like UP means high school students, higher secondary school students, and then we have the college for UG. We have programs for PG students. We have scholarship which we give for PhD, which we give scholarship for postdoctoral fellowships, and then after that for working professors or faculties we have certain programs, and even after retirement we have a scheme known as emeritus scientist, which this is a plan especially focused on the say eminent scientists who have retired or faculties who have retired. And then we have few programs in which we target some rural innovators, which we call it as rural innovators meet, in which we promote the findings those come from the rural areas of the state. And then we have many other schemes which promote the innovators, young innovators, and so on. So just very quickly, I'll just move the slide so you can get in a glimpse of the activities by KCST. So this is we have one of the department, which is human resource development. So here we have all this scholarship which we give to the PhD students as well as the postdoctoral fellows. Then we have ecology and environment program, which majorly aims in areas related to ecology and environment. Then we know about the Kerala Science Congress. So every year we conduct the Kerala Science Congress, which will be normally inaugurated by the Chief Minister of Kerala. This year we had it in last year we had it in Idukki district. So next year most probably it will be in Kasaragod district. The children, some of the students here, they have already attended the Science Congress last year. So there are, you can see other programs like Rural Innovators Meets Tech Fest. Last time it was from CUSAT, and this year also we'll be organizing the fest. And we celebrate National Science Day and National Technology Day. Technology was there in last month from NIST, I guess. And then we give certain awards, like which is totally for people into science, which includes Kerala Shastra Puraskaram, Science Literature Award, Young Scientist Award. These are all given by KCST. And then we have some infrastructure development program, especially for there's a program named Shastra Poshini, in which we develop labs. So in some school, if they don't have labs, we develop science labs, where we provide all required basic amenities, including microscopes or whatever related to chemistry, physics, and biology experiments. We purchase the equipments and we set up the lab in those schools. This is one of very prestigious programs of KCST. And then we have certain technology and development and transfer programs. And this is also very interesting program of KCST, especially aiming the women. So here we have the back to lab. So when women after marriage, if they have a break from the career or break from the studies, we provide them back to lab scholarship. And again, we have this Poshni, not Shastra Poshni, other scholarship for women too. Then, as I said, we have this academic industry meet and other programs aiming at innovation and entrepreneurship. And we have a biotechnology commission. So it also, many researchers or many programs of this mainly focus on the biotechnology theme. And apart from that, we have certain special programs like, say, APJ Abdul Kalam Youth Challenge, where we provide funding for young innovators and such programs. So apart from the grant we get from Kerala government, we also receive a good grant from the central assessment, or DST, DBT grants are also available for us. So just about our R&D center. So one we have in Calicut, that is CWRDM, which is Center for Water Resource Development and Management. So mainly the water management sector they handle. Then we have Kerala Forest Research Institute, which is located in Pichi, Thrissur, where the research related to forestry is carried out. And then we have Kerala School of Mathematics, again in Calicut, which is mainly focused on advanced learning and research in mathematics. Then we have NATPAC, which is aimed mainly to do the research related to transportation and traffic. And then we have this botanical garden, which is in Trivandrum, this JNTBGRI. So it's something which is related to tropical plant resources. And then we have an institute for basic science. Again, we have a botanical garden in Calicut, which mainly focus on aquaculture related species. And then we have a new institute, that is Institute of Climate Change Studies. So in one of the science congress, we got a suggestion because of this prevailing climate change issues. A suggestion came that we can establish a climate change study institute. So based on that, we have established a climate change institute. And then we have three grantees. One is TIC, and we have IRTC in Palakkad, and we have MSSRF in Wayanad. So these are our grantee institutes. So coming to the Crystal program, so as I said, last year during introduction and even sir said, like last year IIT Palakkad organized this program. So again, we are back here for this particular program. So just moving to the major objectives of the program, as you can see, it's majorly aimed to create platform to nurture India's budding talents and to expose the young students, so young minds to the state-of-art research facilities. That's another objective. So our main aim is to give you exposure. Like I know most of you who are students of Crystal, they have already visited the National Children's Science Congress. So for them, we thought we'll give some more exposure to the National Institute of the State. So normally you conduct it in ICER. Last year we have conducted it in, not last year, before we have conducted in ICER, we have conducted it in the Fisheries Department, in CSIR labs, we have conducted in JNTPGA, right? So before that, no, last year we conducted in IIT Palakkad. So the program, as you know, normally we target the state level winners of National Children's Science Congress. So 32 students from who are the state level winners, they get the opportunity or say to be a part of this particular program. So I think most of them are here, except few, like 2 or 3, they couldn't come because of some personal reasons, but others all are here for being a part of this program. And this time it's a 10-day program in which I can say you'll have a lot of interesting session covering different areas of science and technology. And I would also that games and sports will also be a part of this particular program. So please enjoy the program and stay here. And And as I said, last year, IIT Palakkad has conducted the program. These are some of the photographs of the program conducted last year. We got a very, very positive feedback from the students and also from the parents of the students who participated in this particular camp last year. And special thanks to Dr. Rosita. She was organizing the program last year. She organized the program last year. And so we decided that this year also we'll conduct the program jointly with IIT Palakkad, and we hope this program will be very successful and fruitful for this year too. And I would like to thank Dr. Bipu. He is coordinating the program this year, and also special thanks to all the students, because I know you're coming from different parts of the state, and since June 1st is the school reopening date, and still you make it here, like from 20 to 31st, it's like very crucial date time for you to say end of the vacation. So anyway, thanks to all the students and parents for bringing the students here from different parts of the state. And thank you, sir. And thank you all the volunteers and say coordinators of the program. Thank you very much.
Thank you, Dr. Neetu. And I was sort of very eagerly looking forward to the next lecture also. So I sort of cut short my speech. But I should thank Dr. Vibhu and the team of faculty and students who are going to be, who have been running around and who will be running around the next few days to conduct all of these events. And I'm very grateful to Professor Ramanujam for being here for this talk. I'm eagerly waiting to listen to you, but I think we'll have the formal introduction first. Thank you.
Now, we are happy to have Professor Sundararaman, a close friend of Professor Valsakumar, in the audience. Professor Sundararaman is a scientist who has spent most of his career at Metallurgy Division of Baba Atomic Research Center. He holds a PhD in physics from University of Bombay. He was professor and dean of School of Engineering Sciences and Technology, University of Hyderabad, from January 2011 to July 2014. From July 2014 to December 2021, he was a member of the Department of Metallurgical and Materials Engineering at IIT Madras. We invite Professor Sundararaman to address the gathering and to speak a few words about Professor Valsakumar.
First of all, I thank IIT Palakkad for giving me an opportunity to talk to these brilliant young minds who had come here and assembled to participate in the Science Quest and Crystal program. Okay. What I will try to do is that how can you relate to Professor Valsakumar? That is what I wanted to discuss about it. Some of the few qualities of him which you can emulate. Valsakumar was an excellent student in his school days and college days. He was an excellent researcher and was a great humanist. Some of these aspects I will talk about it. Okay. All of us know Valsakumar, many of us, his family and his friends and admirers, and many of the students, they know how great a person was. Because of that, after his death, we decided that we should carry forward his legacy and philosophy to future generations. That is why this Science Quest, as well as another scholarship program for MSc Physics students, was started at IIT Madras. He did his BSc Physics from Brennan College, Talasheri. Then he did MSc from Calicut University, first batch in 1975, and he got a gold medal. Then he joined BRC as a scientist for 1 year as a training school, and from there joined IGCAR. And he was in IGCAR from 1976 to 2012. After that, he joined the University of Hyderabad. He was along with me there in the School of Engineering Sciences and Technology. And then from there, he came to IIT Palakkad in 2015. And he was here till his death. The main thing which one can learn from Valsakumar's life is essentially what it is that how do we learn things? That's a very important question. That's when you are young. One teacher teaches the subject that is as per whatever is given in the syllabus. If you wanted to learn more about it and your natural curiosity has to be kindled, then the best way to do is use library facilities which are available in the colleges and schools. Okay. What Valsakumar did was that he used to befriend the librarians and he used to have one of the duplicate key of the library when he was even in IGCAR as a scientist. So 24 hours library is open for him. Anytime he can go and use the library and learn. That is how he acquired a lot of knowledge about various aspects of physics as well as mathematics. Another thing also which is important is not only acquiring the knowledge, the curiosity to learn the subject and anything which you see in front of you, whether you see, you hear, you touch, using all the panchendriya, okay? That's the science behind it. You should think, what is it which is happening? Don't believe in anything blindly. Question, then you will naturally think in the right direction to get an answer to it. This is exactly what he did. The present day, what you can do, present day, you know that you are studying in where you don't even have to go to library, but you have all the information is on your fingertip on the mobile phone, right? You can access Wikipedia, every information which you want, you can acquire. But what is important is you should not use this just like a novel to read. Every step which is being given there, when you work out, then only you get a deep insight into the subject. That you should make it as a practice. Valsakumar was an extremely sharp person, okay? And that's because of the knowledge, and he was fearless also. He has that quality and the capability to question and ask many probing questions to colleagues, to himself first, then to colleagues, then to visitors who come and give lectures to the institute. I know on many occasions, many visitors were quite uncomfortable talking in front of him. They know that he can ask very sharp questions. This is something which all of you should develop. Don't be afraid of anybody. Nobody can do anything to you. Question if you don't understand. Otherwise, you are living with the lack of knowledge, without understanding. That should never happen in our life. This is only one life which we have. So we should be utilizing this and question if you don't understand. Every teacher and every lecturer will explain to their capability what they understand. Okay, so this quality he exhibited right in his MSc days. So the professors used to call him as the voice man in the backbench. They will say, what is your final opinion on the subject after all the discussion? That is the way in which in his college, the teachers used to address him. I feel that that is something which one should be proud of. That's if some teachers consider you as a voice man, okay, that's nothing more than that you can expect. Okay, and he was equally good in physics as well as in mathematics. He had such a passion for teaching that when he came to University of Hyderabad, almost 4 to 6 hours daily he used to take class. At least 2 classes minimum he used to take in the regular class, and then the students will tell that we have some doubt, we wanted to meet you. In his room, he will say that you'll come. I had seen that anytime you go, he will have some 6 or 7 students who are there with a board. He will be just teaching them. That is the passion which he had for teaching. And he was a great humanist. He understands that all students don't come from financially the same background. Because of this, he used to support students liberally. Many students, he used to buy books for them to study. Computers, when they required, he used to buy and give it to them. Various other things which are required for students to learn the subject, he used to help them. Okay. Apart from all these things, as I mentioned, he's a very fearless fellow. So he used to fight for, if any injustice is there, he will say that, no, this is not correct. Anand might be knowing it. He can tell bluntly that this is what he feels, his opinion about it. He used to fight for it, for the faculty and his colleagues, as well as for students. In fact, I consider him he considered him as a true students dean who used to represent the students' problems and get them resolved. Okay. What I would just in summary, one word, if you ask me, I'll say that try to emulate, because I can go on talking about Valsakumar for as much as I want, as many time as one day, because I had a great association with him since 1975. But what I would tell is that try to emulate some of his qualities, okay? And this may help whatever I mentioned, a few qualities like using the library facilities and curious and trying to question things. And this will help you in your education as well as in career. Okay. I will request all of you, I'll tell that you enjoy this program, okay, and question all the people who are demonstrating to you and try to learn from the answers which they give. I wish the program all a great success. Thank you very much.
Thank you, Professor Sundararaman. Now, it's time for our inaugural lecture. We are very happy to have Professor R. Ramanujam among us. I would like to invite Dr. Deepak, Associate Professor in Department of Computer Science, IIT Palakkad, to introduce Professor R. Ramanujam, who will be delivering the inaugural lecture.
സ്പീക്കറുടെ പേരെല്ലാവരും കേട്ടു. പ്രൊഫസർ രാമാനുജൻ എന്താ ചെയ്യുന്നതെന്ന് ആർക്കൊക്കെ അറിയാം? വാട്ട് ഈസ് ഹി? ഹു ഈസ് പ്രൊഫസർ രാമാനുജൻ? ഹീസ് എ ടീച്ചർ ഓഫ് കോഴ്സ്, പക്ഷേ ഹീസ് ഓൾസോ എ റിസർച്ചർ. അല്ലെ, നമ്മളിപ്പോ പല കോൺവെർസേഷന്റെ ഇടയിലും റിസർച്ചർ എന്ന പേര് കേട്ടു. ഹൗ മെനി ഓഫ് യു നോ വാട്ട് ഈസ് എ റിസർച്ചർ? എന്താ ഒരു റിസർച്ചർ ചെയ്യുക? ടീച്ചർ നിങ്ങൾക്ക് എല്ലാവർക്കും അറിയാം അല്ലെ, അറിവ് നിങ്ങൾക്കൊക്കെ പറഞ്ഞു തരും, നിങ്ങൾക്ക് അതിലേക്ക് മോട്ടിവേറ്റ് ചെയ്യും. റിസർച്ചർ എന്താ ചെയ്യുക? സ്റ്റഡിങ് അബൌട്ട് പർട്ടിക്കുലർ ഏരിയ. അത് ടീച്ചറും ചെയ്യും, പഠിച്ചിട്ടാണല്ലോ പഠിപ്പിക്കുന്നത്. ഇൻ അഡിഷൻ റിസർച്ചർ വാട്ട് വുഡ് ദേ ഡു? ഒരു പുതിയ കാര്യങ്ങൾ കണ്ടുപിടിക്കും. ഓക്കെ, വേറെ ആരും കണ്ടുപിടിച്ചിട്ടില്ലാത്ത പുതിയ കാര്യങ്ങൾ കണ്ടുപിടിക്കും, അല്ലെങ്കിൽ കണ്ടുപിടിച്ച കാര്യങ്ങൾക്ക് പുതിയ ആവശ്യങ്ങൾ കണ്ടെത്തും, എങ്ങനെ ഉപയോഗിക്കാം എന്ന് കണ്ടെത്തും. അപ്പൊ അങ്ങനെ ഒരാളും കൂടെയാണ് ഈ സ്പീക്കർ. ഞാനിത് എന്തിനാ പറയുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ, ദിസ് ഇസ് എ വണ്ടർഫുൾ ഓപ്പർച്യൂണിറ്റി ഫോർ യു ടു ആസ്ക് ഹിം, നോട്ട് മീ. ഓക്കെ, ഹൗ ടു ബിക്കം എ റിസർച്ചർ, വാട്ട് എ റിസർച്ചർ ഡസ്. ഞാൻ ചോദ്യം ഇട്ട് തരുന്നതേ ഉള്ളൂ, ഉത്തരം ഞാൻ പറയില്ല. നമ്മളെല്ലാം അദ്ദേഹത്തെ ജാം എന്നാണ് കേട്ടോ വിളിക്കുന്നത്. പ്രൊഫസർ രാമാനുജം വലിയ പേരല്ലേ, സോ യു ക്യാൻ ഓൾസോ പ്രോബബ്ലി കോൾ ഹിം ജാം. യു ക്യാൻ ആസ്ക് ഹിം വാട്ട് ഈസ് റിസർച്ചർ. നിങ്ങൾക്ക് റിസർച്ചർ, സയന്റിസ്റ്റ് കുറെ പേരൊക്കെ നിങ്ങൾ കേട്ടിട്ടുണ്ടാവില്ലേ? അറിയുന്നൊരു റിസർച്ചറുടെ പേര് പറഞ്ഞേ. ഇല്ല? ന്യൂട്ടൺ, ഐൻസ്റ്റൈൻ കേട്ടിട്ടില്ല? ആരാ? അബ്ദുൾ കലാം. ഓക്കെ, അപ്പോ ഈ ഓരോരുത്തരും ഇപ്പൊ ഇവരൊക്കെ ഫിസിക്സിൽ റിസർച്ച് ചെയ്തവരാണ്, ഇല്ല, അല്ലെങ്കിൽ ടെക്നോളജിയിൽ റിസർച്ച് ചെയ്തവരാണ്. പ്രൊഫസർ രാമാനുജം ജാം എന്തിലാ റിസർച്ച് ചെയ്യുന്നതെന്ന് അറിയാവോ? ലോജിക്കിലാണ് റിസർച്ച് ചെയ്യുന്നത്. ഡു യു നോ ദാറ്റ്? ഇല്ല, നമ്മൾ പലപ്പോഴും പറയാറില്ല ഒരു ആർഗ്യുമെന്റ് ലോജിക്കൽ ആവണം, ഇല്ല, ലോജിക്കലായിട്ട് ഇത് സ്ഥാപിച്ചെടുക്കാൻ പറ്റുമോ? ക്യാൻ യു പ്രൂവ് ദാറ്റ് ലോജിക്കലി? സോ യു നോ, അതും ഒരു ഗവേഷണ വിഷയമാണ്. ദാറ്റ്സ് ഓൾസോ എ റിസർച്ച് ടോപ്പിക്. സോ യു ക്യാൻ ആസ്ക് വാട്ട് ഡു യു ഫൈൻഡ് ഔട്ട് അബൌട്ട് ലോജിക്. ഇല്ലേ, നമ്മുടെ ഒരു റാഷണൽ തിങ്കിങ്ങിന്റെ അടിസ്ഥാനമാവുന്നതാണ് ലോജിക്. ഓക്കെ, അപ്പൊ ഇത് നിങ്ങൾക്ക് ചോദിക്കാവുന്നൊരു ചോദ്യമാണ്. ലോജിക്ക് ശരിക്കും മനുഷ്യന്റെ ചിന്തയിൽ നിന്ന് തുടങ്ങിയതാണെങ്കിലും പിന്നെ കമ്പ്യൂട്ടർ ആപ്ലിക്കേഷൻസിലും ഇറ്റ് ഈസ് ഗെറ്റിംഗ് യൂസ്ഡ് എ ലോട്ട്. ജാമിന് ആക്ച്വലി ഈ ക്രിപ്റ്റോഗ്രഫി പ്രോട്ടോകോൾസില്, ഗെയിം തിയറിയിലൊക്കെ ലോജിക് എങ്ങനെ അപ്ലൈ ചെയ്യാമെന്നുള്ളതൊക്കെയാണ് ഏറ്റവും കൂടുതലായിട്ട് റിസർച്ച് ചെയ്തിട്ടുള്ളത്. പിന്നെ നിങ്ങൾക്ക് ചോദിക്കാവുന്ന ഒരു കാര്യം, ഈ ഒരു റിസർച്ചിലേക്കൊക്കെ എങ്ങനെയാ എത്തിപ്പെടുക? ഇല്ലേ, ജാം ഒരു സ്കൂൾ സ്റ്റുഡന്റ് ആയിരുന്നു, ഇല്ല, അവിടെ നിന്ന് ഇപ്പൊ ഈ ഒരു റിസർച്ചിലേക്കുള്ള ഒരു കരിയർ എങ്ങനെ എസ്റ്റാബ്ലിഷ് ചെയ്യാം? ഇൻഫാക്ട് തൃച്ചിയില് ഇപ്പോ നിങ്ങളൊക്കെ പഠിച്ചതുപോലെ ഒരു സ്കൂളിൽ പഠിച്ചു തന്നെയാണ് എല്ലാവരും തുടങ്ങുന്നത്, ഇല്ലേ? അവിടെ നിന്ന് ബിറ്റ്സ് ബിലാനിയിൽ നിന്ന് ഹി ടുക്ക് എഞ്ചിനീയറിംഗ് ഡിഗ്രി ഇൻ ഇലക്ട്രിക്കൽ ആൻഡ് ഇലക്ട്രോണിക്സ്. വി ആർ സ്പീക്കിംഗ് ടു ഹിം ഇൻ ദ മോർണിംഗ് ഓൾസോ. അവിടെ പക്ഷേ പഠിച്ചത് എഞ്ചിനീയറിംഗ് ഇൻ ഇലക്ട്രോണിക്സ് ആൻഡ് ഇലക്ട്രിക്കൽ ആണെങ്കിലും ഹി ഡിഡ്ന്റ് സ്റ്റോപ്പ് വിത്ത് ദാറ്റ്. ഹി ടുക്ക് എ ലോട്ട് ഓഫ് എക്സ്ട്രാ കോഴ്സസ് ഇൻ മാത്ത്, ഈ വലിയ നല്ല ഇൻസ്റ്റിറ്റ്യൂട്ടുകൾ അങ്ങനെ ഒരു ഫെസിലിറ്റി ഉണ്ട്. നമ്മൾ പഠിക്കാൻ എൻറോൾ ചെയ്ത പ്രോഗ്രാമിന്റെ ഭാഗമായിട്ടുള്ള കോഴ്സുകൾ മാത്രമല്ല, യു ക്യാൻ, ഇഫ് യുവർ മൈൻഡ് ഇസ് ഓപ്പൺ, യു ക്യാൻ ലേൺ എ ലോട്ട് ഓഫ് അതർ തിങ്സ്. അത് കഴിഞ്ഞിട്ട് ടാറ്റ ഇൻസ്റ്റിറ്റ്യൂട്ട് ഓഫ് ഫണ്ടമെന്റൽ റിസർച്ച് എന്ന് പറഞ്ഞിട്ട് ബോംബെയിലുള്ള ഇന്ത്യയിലെ ഏറ്റവും ഒരു ലീഡിംഗ് റിസർച്ച് സ്ഥാപനത്തിൽ നിന്നാണ് അദ്ദേഹം PhD ചെയ്തത്. ദെൻ ഹി ടുക്ക് ഹിസ് പോസ്റ്റ് ഡോക്. കേട്ടിട്ടുണ്ടോ അങ്ങനെ ഒരു ഡിഗ്രിയെ കുറിച്ച്? അതോ PhD ആണോ നിങ്ങൾ കേട്ടിട്ടുള്ള അവസാനത്തെ ഡിഗ്രി? എനിക്ക് ശരിക്കും പറഞ്ഞാൽ വളരെ കഴിഞ്ഞിട്ട് അങ്ങനെ ഒരു ഡിഗ്രി ഒക്കെ ഉണ്ടെന്ന് തന്നെ മനസ്സിലായത്. PhD കഴിഞ്ഞിട്ട് ഹി ടുക്ക് പോസ്റ്റ് ഡോക് ഫ്രം സിറ്റി യൂണിവേഴ്സിറ്റി ഓഫ് ന്യൂയോർക്ക്. അത് കഴിഞ്ഞിട്ട് ചെന്നൈയിലുള്ള ഇൻസ്റ്റിറ്റ്യൂട്ട് ഓഫ് മാത്സ് സയൻസ്, ഇൻസ്റ്റിറ്റ്യൂട്ട് ഓഫ് മാത്തമാറ്റിക്കൽ സയൻസസിൽ 30 വർഷത്തോളം ഹി വാസ് ഫാക്കൽറ്റി ആൻഡ് റിസർച്ചർ ദയർ. അത് കഴിഞ്ഞ് ഇപ്പോ ബാംഗ്ലൂർ അസിം പ്രേംജി യൂണിവേഴ്സിറ്റിയിലാണ് IMSc നിന്ന് റിട്ടയർ ചെയ്തിട്ട്. ഇനി ഞാൻ നേരത്തെ ഈ ചോദ്യമൊക്കെ നിങ്ങൾ ഇദ്ദേഹത്തോട് ചോദിക്കണം എന്ന് പറയുന്നതിന് വേറൊരു റീസണും കൂടെ ഉണ്ട്. എല്ലാ റിസർച്ചേഴ്സും അത്ര നന്നായിട്ട് ഈ കുട്ടികളോട് ചിലപ്പോ എന്താണ് റിസർച്ച്, എങ്ങനെയാ റിസർച്ച് ചെയ്യേണ്ടതെന്ന് പറഞ്ഞ് മനസ്സിലാക്കി തരാൻ പറ്റണമെന്നില്ല. പക്ഷേ ജാം ഇസ് വെരി മച്ച് നോൺ ഫോർ ഹിസ് സയൻസ് ആൻഡ് മാത്ത് പോപ്പുലറൈസേഷൻ ഓൾസോ. സയൻസും മാത്സും സ്കൂൾ കുട്ടികളുടെ ഇടയിലും മറ്റാൾക്കാരുടെ ഇടയിലും പോപ്പുലറൈസ് ചെയ്യാൻ ഒരുപാട് വർക്ക് ചെയ്തിട്ടുള്ള ആളാണ്. ഡെക്കേഡ്സ് ആയിട്ട് തമിഴ്നാടു സയൻസ് ഫോറം, കേരളത്തിലെ KSSP കുറിച്ച് കേട്ടിട്ടുണ്ടോ? കേരള ശാസ്ത്ര സാഹിത്യ പരിഷത്ത്. അതേപോലെ തമിഴ്നാട്ടിലുള്ള ഒരു ഓർഗനൈസേഷൻ ആണ് തമിഴ്നാടു സയൻസ് ഫോറം. TNSFന്റെ കഴിഞ്ഞ 30 കൊല്ലമായിട്ട് അതിനുവേണ്ടി വളരെ അധികം പ്രവർത്തിക്കുന്ന ആളാണ് പ്രൊഫസർ ജാം. അതേപോലെ തമിഴിൽ ഒരു സയൻസ് മാഗസിൻ TNSFന്റെ ഉണ്ട്, തുളിർ എന്നാണ് പേര്. അതിന്റെ എഡിറ്റർ ആണ്. 2020 ഇൻസ, ഇന്ത്യൻ നാഷണൽ സയൻസ് അക്കാഡമിയുടെ ഇന്ദിരാഗാന്ധി നാഷണൽ അവാർഡ് ഫോർ സയൻസ് പോപ്പുലറൈസേഷൻ നേടിയ ആളാണ് പ്രൊഫസർ ജാം. സോ ഇൻ സം സെൻസ് ഈസ് ദ ബെസ്റ്റ് resource that you have to ask all the questions that you have related to research. Okay, that is my introduction to Jam. Sir, welcome.
Before our inaugural lecture, I have a kind request. Kindly request everyone to please put your phone in silent mode.
Can you hear me? Mic on? Hold it up.
It's on, but not fully audible.
What about now? Better? Yeah. Okay, so thanks very much, Deepak, for that long introduction. Thank you very much. My apologies that I can't speak in Malayalam, like he started off with. But I can understand if you talk, and if I can't understand well, others will help. So please feel free to speak. Also in Tamil, of course, I can speak in Tamil if anybody who wants and ask. So thanks very much. So it's a pleasure for me to be part of this program. I think this is the third time I'm coming to IIT Palakkad, second time to this campus, and I feel at home in this room. Thank you very much for this warm hospitality, and also the occasion of remembering Professor Valsakumar. I know Valsa from when he was in IGCAR. He used to frequently visit the Institute of Mathematical Sciences. We've had a lot of interactions with him at that time, also because of my interest in science education. So we've had, for Tamil Nadu Science Forum, Valsa participated in several programs in Kalpakkam, and that's another association that I've had. So it's also a pleasure for me to participate in a program in his memory. So let me start with formal thanks for this invitation and for IIT Palakkad for all the warm hospitality. So if there are questions, comments for which we don't have time, my email address is here. It's very easy to remember, onlyjam@gmail.com. Right? It's easy to remember. You can write to me if you can't manage time today. So, let me. Okay, so let us start with the. See, I'm going to talk about explorations in science and mathematics. Now, you have to do explorations, but then all explorations take time. Right? Time is a very important factor. Now, he says, okay, 1 hour we are going to do some explorations. So I can only talk about explorations. But you should do at least one now. Right? So here is one. Come on. Don't sit there. You have something? Draw. You have some paper? And take out. Everybody, come on. Draw a 2x2 box. So what is it you have to do? One 2x2 box. Right? And you can put numbers there. Digits 1 to 9. No repetition, distinct digits, right? You understand what you're supposed to do? Draw a 2x2 box. You've got 4 squares. So pick 4 numbers and you put whatever numbers you have. Now you can add them top to bottom. You will get top to bottom 2 sums. Left to right, you will get 2 sums, right? You will get 4 sums. Add them all. What sum do you get? Everybody will get some number, right? Come on. You got it? You got what is to be done? Okay, now I say, okay, maybe let's, I say this, you should put whatever numbers you like, get the 4 sums, add them all, you should get 100. You got what you're supposed to do? You can put 7, 9, 8, 4, whatever you want, right? So if I put, for instance, here 7, 9, 8, 4. What do I get here? I get 15 here, 13 here, 16 here, 12 here. What is the total I get? 28, 56. This is the total. Now I'm telling you, put whatever numbers you want, you should get 100. Is it possible? Is it, what do you think? I want 4 numbers and they should sum to 100. Okay, so here is a, well, right now it's not clear whether you will get or not. Okay. What is the smallest sum you can get? No, no, I said distinct. They all have to be distinct. $20. How did you get that? 1, 2, 3, 4, right? Clearly, there is some logic there. Anything more, you're going to get greater numbers. Okay. And then does it matter which order in which you write them? No. If you say no or yes, I'm going to ask you to prove it. Okay. So this is the point, right? This is what explorations in mathematics is about. I mean, Kritika was shaking her head no. Right? Then I have to say, prove it. Right? Right? You have to prove it. I'm not going to accept this if you say order doesn't matter. I claim order matters. You have to prove to me that it doesn't matter. Right? You get the point, right? So, should I write your 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4? There are so many ways. How do I know that, right? That it doesn't matter? Am I going to get the same sum? Whichever order I write? Not clear. Not clear. Do you see? Some orders give you some numbers. Okay. So, of course, what is the? Obviously, if somebody asks what is the smallest sum, next question, natural question to ask, what is the largest sum you can get? Right? So that what is the largest sum that you can get? Anyone? Try it out, come on. Clearly, which number should you be trying? Instead of 1, 2, 3, 4, you're going to try 6, 7, 8, 9. Okay. How should I put 6, 7, 8, 9 so that I get the largest? Yeah, what is that?
Any order.
Any order? Fine. But I want to get the largest, right? So tell me then. Come on, it's one number. Has anyone got? Yeah? 60. How did you get it? Want to come and shoot? Yeah? Or you tell me and I'll write. Yeah. Okay. Yeah. 9. 8. Oh. And now you got your answer. 15, 17, 13. That's 60. Very good. Okay. But why is this the largest? She claims she can get something bigger. Of course, then she has to show it. But you claim it's the largest. Why? See, whichever is the largest number, look, this one is participating in which sums? Here as well as here. Right? Okay. What about this one? It's also participating in 2. So is there some argument that you can give that this is 60 is going to be the biggest? I am not going to answer these. I'm here to tell you what it means to do explorations in mathematics and science. My point is that just now Professor Sundaraman sat down saying ask questions, right? He was only talking about asking questions to your teachers. Equally important is ask questions to yourself. Here you are asking questions to yourself. I think, yeah, enough in a moment. Yeah. Okay. So this is the idea of exploring. All we have is these numbers here, right? So certainly if 60 is the largest, you're not going to get 100. Now I can ask, what about 32? Put some numbers there so that you get 32. Can you get? What should I do? How should I try? How do I get 32? Okay, so this is what I was starting with. And okay, now comes the how many solutions exist for whichever number now we try. Yeah. What about allowing repetitions? Can you get 100? Anyone? No. What will be the largest? Anyone? Supposing I allow repetitions. Yeah, you wanted repetitions. Really, you got repetitions. Did you want repetitions? Oh, you asked for repetition, right? I've given you. Now tell me what is the largest I can do. 72, right? Because 9999 is the largest I can get. 18, 18, 18, 18, 4 times 18, 72, right? So 100 is not going to happen, right? Now, okay, this is not the point. I'm going to have more these things. What kind of questions? I mean, this is one little exercise, and you can do this with, come on. Yeah, a lot of these guys are saying, what is this? You're wasting my time. This is for class 3 or class 4. Here I am sitting with, I've come to IIT Palakkad and I want to do current research, and you're wasting my time with all this primary school stuff. Well, how well can you extend this? So there are 2 words that are very important for all explorations. Extensions, generalizations. Okay, this is something that all people who do any mathematics truly love. Can I extend this? Can I generalize this? How far can I go? I mean, what is this 4x4 box? Huh? Right? And pick something 1 to 9 digits. Can I go further? Can I extend? What kind of questions can I ask? So for instance, suppose you have said this is the smallest. By the way, allowing repetitions, what is the smallest? 4. 1, 1, 1, 1, 2, 2, 2, 2, 8. Right? Okay, thus every number between 8 and 72. For every number in between, is there a solution? Are there multiple solutions? How do you say different solutions? How are they different? Okay, and there are going to be lots of questions of kind that you can ask. You can ask yourself, and then and then you open the door. There's a lot more happening here. For instance, what if I allow 0? Why not 0 to 9? What happens once 0 comes in? Without repetitions, with repetitions, all that. And then there's nothing particularly sacred about this particular shape that you have got. Can I arrange them in different ways? Ask more questions. And yeah, so this is something that you can start and at any age and do, right? So there are lots of ways by which you can go further on explorations of this kind. What about geometry? Right? Now, geometry is where I hope you have a lot of fun. And if you don't, please go back to geometry, work with your teachers, friends, whatever. There's a lot of fun to be had. Here's one thing that you can try: matchstick geometry. By matchstick geometry, what I'm saying is that suppose you've got a bunch of matchsticks, use matchsticks hopefully so that they're safe without all that thing. And what kind of shapes can you make? Right. So, for instance, can I make a shape like this with matchsticks? So I give you 5 matchsticks. Ask you to arrange this in a square with one matchstick along the diagonal. Why not? What's wrong with that? Of course you can do, no? 5 matches. Can you do that? Diagonal should be longer. Why? Hopefully all the matchsticks are of the same dimension, right? That's what I mean by matchstick. I hope actually matchsticks are going to vary a little, but let's assume that they are all actually the same length. But if I have the same length, suppose if I consider this length as one matchstick, and this is one matchstick, what is the length of the diagonal? √2. Is there a √2 length matchstick? But you won't get it in your matchbox, no. So actually a picture like this is not possible. This is a shape that you cannot generate with your matchstick geometry. Okay, so once you realize that there are shapes that are not possible, of course you should ask what shapes are possible, what shapes are not possible, can I characterize it? Are there theorems of matchstick geometry that are different from the theorems that you have learned in your geometry, and so on? I assure you there's a lot of fun to be had, and we've done this with many children like you to do it on the floor, come up with various shapes, draw some shape and see whether it's possible or not, explore. Much fun to be had. And that takes us to something which is, has it come? Leads us to more challenging question of integer geometry. Matchstick geometry, okay. Integer geometry is one where you are looking at all, everything has to be integer, right? You are looking at all sides, length should be integer, diagonal should be integers, whatever. And you have, for instance, you can have definitions like this. This is a standard definition that we use. The perimeter of an integer quadrilateral. What's a quadrilateral? 4 sides, okay. Now I have my 4 sides. What is the perimeter of a quadrilateral? For an integer quadrilateral, it's defined as the sum of the sides as well as the diagonals, right? So if this is my quadrilateral, the perimeter of this quadrilateral is the sum of all the sides plus the diagonals. Now, okay, what is the smallest perimeter of an integer quadrilateral? This is not an easy question at all. Okay, now you will find that when you start exploring integer geometry, you will come across names like Gauss, Euler, beautiful theorems by Euler in this. And this is the sort of thing that's kind of out of fashion because mathematics has moved into a lot more abstract stuff. But people like Euler played around with notions like these, right? 19th century mathematicians had a lot of fun. Integer geometry is actually difficult to prove theorems with. So I wouldn't immediately say that you launch into it. But for those who have done, again, kids like you have done very, very good work with integer geometry. I've seen nice work, something that you can try and have fun with. And I assure you, there are beautiful new theorems to be waiting to be discovered in integer geometry. Again, I'm just throwing ideas here. There's a lot of work that we can do. And what about your own shapes? I mean, in fact, geometry is a lot of fun because, forget these mathematicians, right? You do your own geometry, right? And there is a lot of fun to be had. What shapes do you know? Triangles, right? Isosceles triangles, equilateral triangles is what you learn. What about isosceles quadrilaterals? What are isosceles quadrilaterals? Two sides equal. What's the problem? Do you know any isosceles quadrilateral? Square rectangles are all isosceles quadrilaterals, but you have more, surely, right? What about equilateral quadrilaterals? What is an equilateral quadrilateral? A square, right? Okay, what about an equiangular quadrilateral? What does that mean? Again, a square, right? So this is just playing around with words. I'm just playing around with words. But if you start playing around with words, surely you can go further. How about triosceles pentagons? Why not? What is stopping you from thinking about triosceles pentagons? What are triosceles pentagons? Three sides equal. Now, question is, create your own geometric shapes. What properties can you find? It's not about just defining something and sitting back. That's not the spirit of what we are talking about. You should be able to prove some properties of these things. Again, I'm just saying this. If you give me an afternoon, we can sit together and we all start exploring these things. I assure you, in this room, we'll find new properties in this. I wanted to show you at least one to say that, this is my dear Bhavna, who's in class 9. She came up with a penta-equi quadrilateral nonologue. I assure mathematicians, only school children can think of such structures, right? What a pain to think of a nonagon, which means what? How many sides? 9 sides, of which 5 sides are equal and 4 sides are pairwise parallel to each other, right? And she actually drew constructions of these, proved very nice properties of these, came up with formulas for, what else do you do? Formulas for perimeter and area is what you're taught. She was sitting and doing these things, right? Now, to me, this is the spirit of mathematical explorations. You've been taught something, certain kind of formula, certain way of analysis, and I go ahead and look at whatever there is in the world and I apply what I have taught, right? And in the process, you learn geometry in a way that this thing. So for, like this dear friend of mine, this Bhavna, there are many in this room, right? There are many who are, you are sitting here, you can create your own geometric shapes, but in the process, your insight into geometry changes quite dramatically. This is what is different from, like what Professor Sundaraman was saying, listening to somebody and saying, okay, this is what to say, I want to learn. How do I learn, right? How do I learn to learn, right? So how did these people come up with all those great things that they did? When I went into TIFR as a PhD student, I thought they were all gods. All these guys walking around are all gods. Because, see, reading a textbook was difficult enough. And these people were all proving their own theorems. And anybody who proves his or her own theorem must be a god, right? This is difficult enough understanding other people's theorems. It took a while to realize that, okay, gods also have feet of clay, right? You can do it. You can prove your own theorems. Nobody had told me that theorems doesn't mean that, all these dadiwalas prove theorems, right? So theorems mean you can do it yourself, right? And these are things that I assure you, you start thinking like this, there is at least one theorem waiting, which, all these mathematicians haven't thought of, right? For various reasons. Some things are important, some things are not important. It takes a lot of work, experience, intuition before you realize what is important. That doesn't matter. You shouldn't be worrying about it at this age. You just want to get into the spirit of explorations, right? Because you want to understand, right? And investigate mathematics. And there is mathematics on the street, right? I mean, I grew up looking at columns. Columns everywhere. I'm sure Palakkad has columns in January. Columns are something that you find on the street, literally. And it's highly gendered. Being a good alpha male, I never learned to draw columns all my life in Trichy. And it is through my experiences in adult education. In the 90s, I was doing a lot of work in adult education. In my adult classes, I was trying to do mathematics. And then I realized that they had a very rich resource of mathematics in their hands. They were all drawing columns. And it was also a good way of reversing because they would teach me how to draw columns. And I learned columns from them, and they had great fun making fun of the fact that I was totally clumsy and couldn't draw properly. They enjoyed that whole thing. But in the process, we saw a lot of mathematics in columns. Right? Have you seen these pulley columns? Look at these. So the ones on top are what are called kami columns, and the ones are below are called pulley columns. And look at the D, E, and F. Look at those intricate. What is going on? You have some dots and you have some curves going around them, right? And this is something, as I said, you literally see on the street. It's culturally rooted. I mean, if you come to Chennai Book Fair in January every year, there are like 30,000 books or something like that. But I assure you, every year you will find at least a few hundred new books on columns, right? This is a rich cultural thing that thrives. It's been going on for a long time. Right? And it's hugely driven by women, largely women who have not had any great university education and nobody from IITs and stuff. Right? It's a cultural thing. It's transmitted, and how do you communicate columns? It's a very interesting thing. So here, for instance, look at how she draws the column. And remember, what I have drawn and the later ones are very small column. She's drawing a gigantic column on this. But what the photograph shows is less than half the column. So there is a fish-like image, and she has rotated it by 90 degrees, and then repeated it. And then what you get is E, something which looks completely different, right? So construction of columns is actually a very beautiful thing to learn. Now my question is, what does it mean to explore columns? I would say explore columns. This is something that you can do, right? Question is, what questions would you ask? When somebody shows you columns like these, what questions can you ask of columns? Earlier, I was saying perimeter and area and all, and you are happy. Here, I was putting some numbers and saying least sum, greatest sum. But columns, what questions would you ask? Anybody? Anything is okay. So, kuch bhi throw. Come on. You have columns in front of you. What questions would you ask? Yeah.
Maximum numbers of closed shapes we can.
Wonderful, wonderful. How many closed curves there are? You notice one thing about columns. What hits you is that there are no open curves. Right? There are no curves sticking out. Every curve closes in on itself. And you also realize that it's not. Is it, by the way, in F, is it a single curve? Are there multiple curves out there? In D, E, F? Maybe here. In this one, is it a single curve or multiple curves? Here, I think you should be able to see that there are multiple closed curves. So, how many closed curves are there? A beautiful question. Please give him a big hand. Lovely question. That, okay. Any more? What other kind of questions do you have? Anyone? Anyone else? Okay, so think. do, right? Try. That's what explorations are about. Here, one great thing about explorations is there is no JEE for explorations. I'm very happy to say. There are no 10-mark questions, 5-mark questions, and 20-mark questions. One of the saddest things about our school education, what university education also, is to reduce everything to 10-mark questions and multiple choice and whatever. Explorations are about not about that. Don't worry about there is nobody sitting there and giving you 34 out of 100 or 96 out of 100 or whatever. That thing. Do what you want, right? But the freedom comes with a lot of responsibility, right? You have to think, you have to ask, you have to try, you have to do. Okay, and question is, how does one explore a topic? This is what it's about, right? Something like this, as I said, culturally rooted, you see on the street. How do you explore these things? More importantly, how do you explore it mathematically? What does that mean? What do we need for the exploration? Knowledge, skill, attitude, all of this is important. So you do need to build up some knowledge, right? You need to learn mathematics to explore more mathematics. So it's very important. Let's not forget that. You need certain skills, right? And you need, most importantly, an attitude. An attitude for exploration, I think, is the most important. For instance, for exploring columns, and now I've done this column workshops with school children, school teachers. At the Institute of Mathematical Sciences, we ran the first workshop in 1999, I remember very well. And there was this algebraic geometer called Sunita who had come from Princeton. We said, why don't we do this? And we started. It was a lot of fun. Since then, now we are probably, I think, at least I have participated in maybe 50. So it's a lot of fun, great joy, and many children and teachers have come up with various ideas that I have learned from. And my adult education classes, I have learned a lot. One is classification. Remember, classification is at the heart of science. All science begins with classification. Solid, liquid, gas, living, non-living, whatever you like. So you want to classify columns. Take 50 columns. He had one classification index. What is that? Number of closed curves. That's a wonderful classification. Because it says one closed curve, two closed curves, and so on. You get a hierarchy. It's a beautiful term to learn. But maybe there are other ways. Can you think of other ways? I'm not going to answer this. I assure you that there are multiple ways, all interesting. Here, I already written this. This is one of the most natural and beautiful ways. How do you communicate columns? I really don't have time here today. If you let me, we would have exercises and doing that. Right? You've got a column on hand. I'm standing at the board. You have to make me reproduce exactly what you've got on hand. You have to give me instructions. How would you give instructions? For those who know, come up with a context-free language. Right? This is a good challenge. It's possible only for a small class of columns. So it turns out that you need context-sensitive languages for the general class of columns. These are not easy things. But coming up with a formal mathematical way by which you can reproduce columns exactly is a good mathematical challenge. Symmetries and transformations. Okay. One of the things that strike you about columns, by the way, nobody asked what is the definition of a column. This is not easy. In fact, as far as I know, you can't even give a formal definition because it's people's practice. And what people draw are columns, not what you sit in. But you do need some formal definitions to work with. So you can come up with good definitions that come very close to what people do, right? Especially pulley columns. And so you can do that. There are a lot of symmetries that are there. In my workshops, at the end of the workshop, we've had students, drawing columns with 4-fold symmetry, but not 6-fold symmetry, etc. All that you can do. And then transformations. Can I transform this column with certain symmetries to another column with different symmetries? Are there linear maps? Okay, these are harder questions for you to think about, but I assure you that just the world of linear maps is so rich that you can actually do fair amount of linear transformations on columns. And then another one that I like very much is cuts and splices. Suppose I tell you that you can actually cut the column in two places and splice them. Do you understand? I cut it in two places and splice them across, right? So two cuts and a splice is one. Now I tell you, here is a column. It's got, let's say, diagonal symmetry, mirror symmetry, whatever. And you are allowed some cuts and splices. You have to come up with a column without that symmetry, but something else. What is the least number of cuts and splices you need? There are theoretical computer scientists sitting in the audience, I know. Hard questions to answer, right? What is the minimal number of cuts and splices with which you can achieve the transformation that you want? So optimality questions are really hard. With columns, they're actually, provably hard. And it's a lot of fun thinking about these issues. But, you can get to all that later. The thing is to draw. The thing is to do, right? You should actually experiment with a lot of codes, right? And think about them, talk about them, argue. This is the real challenge. Remember, I said I started with this work with an algebraic geometer, right? How do you compare two columns? Can I say one column is more curved than the other? Can I talk about degree of curvature of a column? There is a particular class called Chittu columns. Anybody who has seen Chittu columns know they're incredibly twisty. Just go all around the place. Right? And I only shown Pulli columns. You have to see Chittu columns. They are like perversely twisty. How do you measure the curvature of Chittu column? Right? So can you come up with, again, mathematical means for these? This is, now we are really entering at least undergraduate, graduate level mathematical work. My point is that columns on the street, you can explore in middle school, secondary school, higher secondary school, undergraduate, graduate, all levels. There is interesting mathematics waiting for you. Yeah. If I just take the class of rectangular columns, what are rectangular columns? Just have dots placed in a rectangular form, k by n, right? Rectangles of dots and have curves going around. And so these are called rectangular columns. And you can ask what is the minimum curvature and maximum curvature I can get. Okay, so what is the kind of explorations that we are talking about? If you ask mathematicians, what is doing mathematics? Right? There are like classy mathematicians sitting here. Let's say doing mathematics is many things like this. There are various kinds of, you have representations, right? Like you have rational numbers, right? What is a rational number? Anybody? What's a rational number? Something like 2 by 3, 22 by 7. That's a good rational number. Yeah. So what's a rational number? Yeah.
Anything we can write in the form of P by Q and Q not equal to 0.
Q not equal to 0. Wow, I'm so happy that it says not equal. It's very important that denominator is not equal to 0 and there is no common factor. Right? So that's a representation of the rational number. But you can also think of it as a point on the real number. These are two different representations. Both are important for you, right? And mathematicians always love to choose different representations, go back and forth, and look for new things. Looking for invariances. It's a very beautiful term because when I change something, right? When I take a column and transform it into something else, something changes, something that doesn't change. What doesn't change is very important to understand. And so on. Okay, observing extreme cases and typical ones to come up with conjectures, looking actively for counterexamples. This is something that you do any mathematical work you learn, that proof comes later. You look for counterexamples. This idea that you look actively for counterexamples is like the critical attitude that Professor Raman was mentioning. Somebody says something, right? Okay, let me look for a counterexample, right? That it's not being arrogant. It's part of training. Part of training to say that somebody claims something, look for a counterexample. And when you can't find counterexamples, you start looking for proofs, right? But these are all things that are not in school, taught in school, right? Mathematics has this very beautiful idea that I'm trying with the particular, I'm finding it difficult, and therefore I try general problem. Generalize and it becomes much simpler, right? And so all this happens, right? And very important thing for mathematics is building on answers to generate new questions for exploration. When you solve a problem, that's not the end of the world. Where does it lead to? What extensions can I think of? What generalizations can I think of? And so on. So let me skip all this. Yeah, I'm not going to talk more about this general stuff. These are not easy, but important to do. There are various kinds of exploration: question-driven, concept-driven, goal-driven, whatever. For instance, puzzles, Sudokus, right? You all know Sudokus, right? Have you seen Sudokus? Have you seen in newspaper 9x9 Sudoku? Every cell gets a digit 1 to 9, and you can't have repetitions along the columns, along the rows, and in every box. But if I take filled-in Sudokus, how many distinct Sudokus are there? Not an easy question to answer. It's actually quite a difficult question for the 9x9. How many of them up to symmetries? What do I mean by that? You take a filled-in Sudoku, it's a solution. If I rotate it by 90 degrees, it's still a solution. If I interchange two rows, it's still a solution. If I interchange two columns, it's still a solution. So then you can say they are both the same, because I can get one from the other by just this operation. So you can ask how many distinct Sudokus up to all this. Okay, and try this for 4x4 Sudoku. You know what is a 4x4 Sudoku? There are 4 boxes, 4 rows, 4 columns. Do this, you will get exact numbers for all of this, and it will give you an idea of how difficult it is for 9x9. And there's a lot to explore on this. In fact, I can even ask if I partially fill in a Sudoku, right? You know that all Sudokus come with a guarantee that the solution is unique, right? So in a 9x9 Sudoku, there are 81 cells, right? Hard Sudokus typically would fill about 20, 21, and then ask you to fill the rest. Devil Sudokus, there are various categories, and now question is, what is the smallest number of cells that I can fill in and still guarantee a unique solution? Okay, so that's a hard question to answer. Here is a very simple puzzle. I say that, I have six circles arranged as a triangle. Now I'm asking you to put numbers 1 to 6. You can put whatever numbers 1 to 6 without repetition. Those numbers 1 to 6 should be placed in the cells, right? But in such a way that if I take every side, there are 3 sides, right? The side sums should come to be the same. It's a bit like magic square, right? Now, do it later, because this is a question is how many solutions exist? Prove it, of course. What if we choose any 6 consecutive numbers? Can I get how many solutions exist? What about other shapes? I said triangles. So that is the idea of extensions and generalizations, right? How, for instance, I have had students experiment with shapes like this. Here again, and as the numbers, you should get this thing same. And they have had a whole ladder, snakes, and so you can try various things. These kind of explorations get you into the spirit of all the stuff that I'm talking about. And then you can also have, for instance, I give you a number, right? I give you a positive integer and ask to partition it, right? Sum it in different ways such that the number of parts is odd. Okay, that's something that you can actually try and prove nice theorems about. Here is a problem. I mean, these are all things that I have seen with kids and in different exercises. This was actually, something that a class 9 child asked me from some problem book. Consider 6 towns in flatland. This is from a Russian problem book. The least distance between any two is little m. The maximum distance between any two is big M. Show that big M by small m is greater than or equal to square root of 3. Nice problem. What does it mean to say flat land? You mean on the plane. Towns, you don't worry about it. There are 6 points on the plane. You're told that the least distance between any two is small m. Maximum distance between any two is big M. Now show that big M over small m should be at least square root of 3. Square root of 3 already gives you a hint. Where do you see root 3 by 2 and so on? Come on. If I tell you all these things, yeah? Trigonometry, right? Of course, somebody says. Yeah. So some sine theta cos theta is there. Okay, this is for the older children. So that is the clue that is there. But you will find it and you can actually prove this. And nice problem. Here is another beautiful problem. Show that 5555 raised to the 2222 plus 2222 raised to the 5555 is divisible by 7. The first thing that you realize is that those numbers mean nothing. You actually try to find, this raised to that, you're never going to get anywhere. And that 5 plus 2 being 7 is a distraction, right? All that you realize. But then where do I go? Point is, see, what is your listening to problem solving when you see some horrible problem? Right? Again, this was posed to me in one of our camps by some kid. And, he says, I found it in a problem book, sir. Can you help me? Now, I don't know what is your reaction when you hear it, when you see a new problem. What is your reaction? I don't know. What is yours? Yeah.
Yeah, I find all this is challenging.
For me, it's panic. Panic. Big letters. What is this problem? I can never be able to do it. It's normal. I think as teachers, people should tell it's normal to see a problem and panic. No problem, big deal. You can be great mathematicians. It doesn't mean that you can solve problems. It's perfectly all right. But point is not to give up at that, right? That is the thing. You don't give up. You look at it and say, stare at it and say, oh, what can I do? What can I do? What can I do? And invariably, think of all the things that you know. Something starts clicking. Okay, this is some a power n. Okay, it's a power b plus b power a. Okay, that I don't know much about. But I do know about a power n plus b power n. Okay, a power n plus b power n is divisible by a plus b when n is odd. A power n minus b power n is always divisible by a minus b generally. This is what I meant. You need some mathematical knowledge. Bit of mathematical knowledge is all that you need. Something that is there in school textbook already will save you. And actually, this problem you can actually go. And for those who know modular arithmetic and so on, there is a lot more tricks are available. You can actually solve this problem. My point is not that. Problem-driven explorations are of this kind. Right? You start with problems, and there's a whole world out there. Let me skip this. There's one that I did with class 11 children that I wanted to mention. One project, and this was in December 2015 when we had this huge flood in Chennai. Right? After that, something like 1.5 million people were displaced. SBOA group of schools was doing, they were actually, constructing shelters, tents at that time for people to stay. And then they said, how do we design it? And we said, why don't we actually involve our students also in the process? So the project was to design an emergency shelter, a tent. So the question is, how much height is needed for sleeping or lying flat or on your side? Right? Can you make use of the whole floor space? What's a reasonable height at the center for a tent? Right? What should be the angle of the walls of the tent to achieve the height needed in much of the tent? Remember, a tent is going to have a central pole and you have these. Do you want a tent to fit the average person? How many should be there in one? 4 if you say 2 adults, 2 children. What is the size? So all this matters, right, in the design. And what scale will you use for your diagrams and plans? All these had to be done. And this is a wonderful project. Whole lot of curricular areas involved, handling data, because you have to find body measurement to plan the dimensions, for sleeping, sitting, working, etc. Geometry and measures, 3D shapes, 2D representations, nets and construction, angles, scale drawing and measurement, all sorts of quantities of fabric needed, a lot of trigonometry, optimization, some economics. And dynamic geometry software like GeoGebra was used extensively for doing this. We use the internet for a lot of information. It's a wonderful project, where about 30, 35 children were involved, doing various aspects of things and then working together. And actually, the school actually used it for a very important thing work that they did. So this is to show that all this is possible, right? Different kinds of explorations are possible. Some things that are applied, practical, some things that are general, abstract, like that 5555 and 2 to the 2 doesn't matter. They're all mathematical explorations. Let me again skip more examples of this kind, mainly because I wanted to mention, and I've had run out of time almost, right? So let me do a few things in science to talk about. This is my favorite question, which I always ask when I meet school children. What is the boiling point of water? 100 degrees Celsius, that's all? Okay, clear? Sorry?
You have to mention the temperature and the pressure also.
Okay, he says more. 100 degrees Celsius at room temperature?
No.
Sorry? 100 degrees Celsius and something more? At some atmospheric pressure, somebody said, okay. My question is not that. How do you know? How do you know? How do you know that this is the boiling point of water? Yes?
How does water?
Huh? You study? Huh? Sorry?
How does water?
That is a deeper question. I am only interested in how she knows. You study about it. Where do you study?
Most of the time we see it in the textbook also.
Okay, it's there in the textbook. Okay, let's be clear about it. Okay, you can do an experiment to find out. No? How many have done this experiment? On boiling point of water? Okay, so, okay, here is Anand saying he has done it. I have done it. I have done it many, many times. Right? Again, I have done it not as a school student. I didn't do it as an engineering student. I have done it in Tamil Nadu Science Forum and I've been working with school teachers and students many, many times. And one thing I can guarantee, and by the way, how do you do this experiment? How do you find out the boiling point of water? Anyone? How do you find out? Yeah, you take some water, you take it in a baton, right? Have some heat source, adupu, right? And boil. And what do you need? You need an instrument, no? Thermometer. What kind of thermometer? Not your clinical thermometer for your jwaram, right? That doesn't have the range. What is your body temperature typically? Somebody? Huh? 90s. Okay. We are talking Celsius. You said 100 degrees Celsius. So what is your body temperature in Celsius? 36. Okay. Happy. Not 40, not 45, not 50, certainly not 100. So there is no hope of your clinical thermometer finding out whether water boils at hand. You need a lab thermometer. How many people have seen a lab thermometer? Oh, good. Okay. I don't know whether all IIT Palakkad students have handled the lab thermometer. If not, that's a good parameter to make sure, right? I hope all children, all secondary school, higher secondary school children learn to handle a lab thermometer. This is something we should do. I'm afraid, I'm sorry that our schools do not let you do this, but it's an easy thing. Any medical shop will have a lab thermometer. You can borrow it and use it. We have done it many times in our science forum workshops. But that's not the problem. I've done it many times, right? Like I said, we have 50 students. We have 10 places where we boil water, we take, and what do we find? We do the experiment, we buy these lab thermometers, we do the thing, and we find that it boils at 100 degrees centigrade, right? Of course not. When I do the experiment, I never get 100. I've done it many, many times, 50 times. I never get 100. What do I get? 99, 98, I've got 102. Okay. Now what do I do? I go down to class. Do I say water boils? What am I supposed to say there? Water boil. I mean, he said you have to do experiments and find out. In fact, the only answer that anyone will say in science is not by what the textbook says. Do not believe the textbook. Do not believe your teachers. Ask Professor Sundararaman. But you do it and see. That's supposed to be the spirit of science. What the experiment reveals. My experiment reveals that water boils at 99.8 degrees Celsius, not at 100 degrees Celsius. So how do I? Is the book lying? Here's the question. Is the textbook lying? I have not done it once. That's why experiments, you don't do it once. How many times do you do your experiments? 10 times, take the average. Have you done that in your record books and so on? Record books is another beautiful thing that we have in our science education. In Tamil we say Muttumuta, Manimaniya, you write it beautifully. Record book has to be beautiful, right? Everything, all tables beautifully done, graphs beautifully done, nicely bound and submitted, and you get good marks. I'm very happy that you get good marks, but please, my dear friends, that's not science. You look at log books of scientists, there is sambar on it, chicken curry on it, I don't know what all, it's dirty, messy, but they are genuine log books. They are data collected by scientists doing that. That is not all this beautiful stuff. World of science is extremely messy. Go to labs, sit with this thing, it's horrible. Natural scientists operating in the wild and keeping log books, you see, it's torn all over the place, but it's genuine data. So when I do this experiment, repeat it and take the average, I'm getting genuine data. So I've got my average as 99.6. So I should say water boils at 99.6, no? What happened? So tell me, is the textbook lying? Shouldn't you be writing to, if you did this experiment, I mean, we did this in Tamil Nadu, so we should be writing to Tamil Nadu State Board saying your book is lying. So is that the right thing? What should we do? Why do I never get 100? Which water are we talking about? Well water, tap water, Chennai's metro water, Bisleri water. I don't know what this is. This is called some Vedika water. Vedic water, even better, right? So maybe Vedic water boils at 100 degrees Celsius. So which water are we talking about? I've seen many students in that point say pure water. Indians love purity, right? I don't know where this pure comes from. What is pure water? H2O, somebody says. There's no such thing as H2O. That is two molecules. You can't have boiling and all at the level of two molecules. Right? So something is going on. What is it? So science explorations are, forget mathematical explorations that I'm talking about. Science explorations are of this kind. It's everywhere around you. Every page of your book is an opportunity for exploration. Right? There is a lot that you can do. I'm not going to go on with this. I've done these kind of projects with school children. What's the boiling point of sambar? Sambar has boiling point, no? Well, which sambar? My house, well, your house sambar, whatever sambar you are having, right? You know that sambar has puli in it, right? What is puli in Malayalam? Okay, you know that. I hope you know that sambar has puli in it. Now, if I increase the concentration of puli in sambar, will the boiling point go up or go down? Yeah? Go down. Why? Yeah, something. Why? It's an interesting question. Interesting answer, but why? Somebody said puli is an acid. Now, if acid content increases, boiling point decreases is what you are saying. Is that true? Why? Does it also mean that if I increase some alkali content, boiling point will go up? Why? Don't answer these things. If you are answering like this sitting in your armchair, there's a problem. Do the damn experiment. You have done this with children, right? Because I'm not going to stop once you tell me, supposing you say it go down, and you show that it goes down. What is my next question? Goes down by how much? Give me a quantitative answer. Draw a graph, right? Is it a linear relationship? Is it a quadratic relationship? After that, I want an equation. Can you plot, give me an algebraic expression for it? And so on. It's when you do all these things, right? You ask the question, you do the experiment, you vary, do tables, draw graphs, come up with formulas, do all of this, then you're doing science. And science is at its best when you do these things. As I said, I've had children do these things. They have done boiling point of sambar, boiling point of chicken curry, boiling point of which has a higher boiling point, cow's milk or buffalo's milk? Wonderful question, right? Kids did wonderful projects of this kind, right? And boiling point of milk is not easy because why? When you try to measure it, what happens? Milk will boil over. You do it too soon, it's too low. If you do it a little late, again it has come down. So how do you make sure? So kids did a wonderful instrument where they had this 2 sticks and 1 stick sticking out, to which they tried the thermometer. So one kid sits and pulls the thing, pushes it up, so the thermometer lowers. Just as the milk starts boiling, you pull it out. Somebody else does that. Nice instrumentation. Okay, so what about this? How long does it take for a wash shirt to dry? You do it every day, no? You put it out in the sun. How long does it take for it to completely dry? Do it, find out. Under what conditions? How long does it, under, when I say what conditions, there's a lot, no? Different cloth, you can vary the cloth, you can vary the different conditions, where, how long, and when you say, how do clothes dry? By a process of evaporation. How did then the water content in it boiled and evaporated? What happened there? Try to explain the phenomenon. Try to quantify it. Draw graphs, finally draw graphs. Come up with formulas. I wouldn't accept it until you do that. There is a lot to be done there. For instance, how long does it take for an ice cube to melt completely? Say 5 centimeter by 5 centimeter ice cube. How long does it take? Again, what are the parameters? Right? Ice inside, is that all there is to it? Under what conditions? If I wrap it in sawdust, what will happen? Will it take longer? And so on. How long does it take for things to decay? I can go much further. Leaves, paper, wood shavings, plastic. We have done this in many schools, right? And at different places. You dig a pit in one place, put some leaves, watch every day what happens. Cut up paper, put it in a pit. Open every day and watch what happens. Record, have a nice record book. See what happens to each of these. Vegetables, and see what happens. And especially vegetables, if you put it in a pit and watch every day, you can see, suddenly you see a whole lot of organisms out there. Where did they come from? Do they come for paper also? Or which ones come? So from that little how long question, you can go much further. Instead of reading about, biodegradation, do this. Do this in your school. Put a big poster. Show how things are changing every day. These are observations, and that is genuine data. Right? That you are coming up with the data, you are recording it, you are displaying it, others are participating in it, and under different places. Something in the open air, something under a tree, something in your corridor. How do these things do? So, and then of course you learn about plastic. And plastic is the thing that nothing happens to it. And we now have had schools across the space of 15 years. They can show that this was something that was, started by children in 2006, and till date, that plastic is looking exactly the same. They've got photos to show every year on display, and you can see that what happened to wood shavings and plastic. It's one dramatic thing that I've seen in a school in South Chennai, which is going on. It's an experiment that you're going to continue as long as the school continues. That shows, what you're doing with plastic. That single image teaches you a lot more about plastic than a whole lot that you read about. This is a project that I wanted to mention for a particular reason. If you take, these days, you people don't even know what blotting paper is. A paper will simply absorb, right? And take ink, again, something that most of you don't know. You take ink in a filler, and I just release a drop from a height. When it falls on paper, what will happen? The ink falls and it spreads in the form of a circle. What's the relationship between the diameter of the circle and the height from which the drop is dropped? It's a very interesting exploration to do, because as you vary the height, when it's lower, you will get particular kind of circle, and as you go higher and higher, and after a point you can't see any proper shape at all. It scatters. There is a scattering point that you can study, but more importantly, what's the relationship? Other liquids, what happens instead of ink? If I take coconut oil, what will happen? In Kerala, you have to do it with coconut oil, no? What about other oils, other liquids, other surfaces? Wood, if you do, what happens? I'm mentioning this point, this experiment, because this is what got me into engineering, right? There was this thing called National Science Challenge Scholarship. You did experiments. In my school, I did this experiment. This is what this thing, and I got a National Science Challenge Scholarship, without which I could not have gone for undergraduate studies at all. Only by National Merit Scholarship, I could actually learn, go to Pilani and study. So this was a science project that actually got me wherever I am. So it's really, so science projects, explorations can also get you things in life. How things work. Take a bicycle apart, put it together. Not easy. Watch, go to a garage and see, mechanic working with the cycle repair shop, you know how they do it. You watch them do. Spend half, we have brought cycle mechanics to classrooms and done this, and it's a great thing to learn. So this connection between science and technology is something that we don't learn in school. I know I'm sitting in IIT and talking about it, but an attitude to technology is completely absent in our science classrooms. Ballpoint pen, right? How does this work, right? How does this work? How does this come about? I mean, where is the ink? How does it come and take a shape of what I'm writing? Have you looked at that? It's a beautiful piece of technology. It's there in your hand. How does it work? Toothpaste, right? Toothpaste, it's easy to squeeze out. Can you put it back into the toothpaste? Not without a huge amount of, energy. I mean, you need it. In fact, it's very non-trivial to even try to think of to do a calculation for what it might need. How does the ceiling fan work? So just look around. These are all questions that you can ask, right? I mean, if you think about a big lorry, right? A big truck, right? Think of a big truck carrying heavy stuff, right? And how does the truck stand? It's heavy, big lorry, 8 wheels. How is it standing up? On its tires, right? So what is holding up the truck? The very heavy truck is standing up. What is holding up the tire? The tires? Air. Finally, it's air. You just put one little hole, one puncture, the whole truck falls to the ground. So the truck can't move at all. So it's air that is holding up. How is it doing that? You've seen airplanes, right? Huge airplanes carrying people, their luggage, all of that. Have you seen those tires? They're very small, those wheels. How is it that the plane, this huge plane, is standing with on these small wheels, those tires again? How is it? What's the explanation for that? Can I calculate all that? Actually, you can. No? You learn about something called Bernoulli's principle in school, right? Well, how does it work? Not to do. You can build up your own thing, your own little tools to see how, for instance, you can push air into polythene bags, our milk bags, and use them to lift up objects, right? Push, do a lot. So these are things that Professor Neetu was showing in innovation under many of these. You can do it. There are a lot of little devices that you can build, right? But no cost at all. That simply using air. And that will actually give you some insight into how all the technology works. So, okay, let me end with this. Which is it the sun that goes around the earth, or the earth goes around the sun? Which one? Huh? It is the earth that goes around the sun. Is there anybody who doubts it? Is it clear that it's the earth that goes around the sun? Yes. But question is, of course, how do you know? Can you prove it? Because every day I see the sun rising in the east, setting in the west. It looks like the sun is going around the earth. But how do I know? Can you prove it? I assure you, you can. Right? With maybe class 10 level mathematics. Right? Maybe class 11. This is not some deep stuff. You can do it, but it's going to take a lot of patience. It's going to take a lot of patience. You need at least 1 year. At least 1 year, why? Because that is the time that it takes for the earth to go around the sun. So you can choose a spot in your school, on a wall, take a particular time. I would recommend some time either in the morning or in the afternoon, not around noon for good reason. And then you spot a point, spot a particular, you have to choose a point at which, your sun rays fall using a shadow perhaps, and you mark the point. As the sun travels from, north to south and south to north, you see what points you get. What should you get? What will you get? Will you get a circle? You will get a shape. You'll get a beautiful shape. A regular shape, in fact. Anybody has any guess on what shape you will get? If you plot all over the year, you get a sinusoidal shape. You get a shape like this. Why do you get that shape? Why is it? And that will give you the proof. So I'm giving you the idea, but it takes a lot of work by a lot of people and of course there is something involved because some days it will rain, right? It will be cloudy. So you have to do what we call interpolation. You see points here, you have to smoothly continue. But when you do all that, something very nice is waiting for you. And these are all things that people have done over centuries, right? And you can do it. And okay, so I think it also says that I'm out of time. So, I don't know why it is. But that's all I wanted to. So end with the thing that, okay, so sorry I've taken so long. This was to show that the spirit of explorations in mathematics and science is something where it's about trying, right? It's about asking questions from things that you see, right? Raman's greatness was asking the question, why is the sky blue? Everybody is looking at it. But then, you look for answers with whatever knowledge, whatever resources you've got, right? Whatever mathematics we know is good enough. Whatever science we know is good enough to start. But then, it's about, if it is in science, it's about working with doing experiments, working with material, right? Wood, metal, soil. In Tamil, we say todu unarvu, right? Somehow you have to touch things. You're sensitive, right? You have to touch things. You have to feel wood. A feel for wood is very important. A feel for metal is important. A feel for soil is important. Without dirtying your hands, you can't do science, right? You have to dirty your hands. And a kitchen garden is a wonderful source of doing science, right? So there is a lot to be done. And so he was asking, what does it mean to do research? Who is a researcher? A researcher is one who does any of these things. That's all. So if you do these things, you are researchers, right? That Bhavna, who was looking at, what was that? Quadrilateral, I've even forgotten. Nonagon. Pentangular nonagon. She's a scientist. She's a mathematician, right? Because she came up with this thing and definition, and she came up with some theorems about it. That's it. So you can do science. You can do all kinds of science and mathematics. And most importantly, once you taste the joy of discovery, right? That's what this is about, right? Once you taste the joy of discovery, there is no getting back. I think, whatever else you can do in life, I think doing science is extremely rewarding for this. Here, I think almost everybody, all of you are from probably same class. I mean, class 9 or class 10 or class 11 or whatever, right? But you say to a different, I usually say I am in, so you are in which class? Class 11. What about you? What about you?
9.
And so on, right? What about you, Kritika? I say I am right now in class 57. I think Muruganandam and I are classmates. So I am in class 57. Next year, you're going to be in class 12, class 13, class 14, and so on. Because this never ends, right? This never ends. I assure you that, especially if you get interested in learning in science and mathematics, this learning is always fun. And probably it'll get much more fun because I don't have to think about 100 marks and, unlike you poor kids that you have to worry about board exams. So it's much more fun as you go along. But a whole world of explorations is waiting for you. Thank you very much. Sorry, I took long.
Thank you, Professor Ramanujan. Now it's time for a few questions. If the students have some questions, you can ask.
He right now said that ask questions, no?
Well, which is easy. Asking questions or giving answers?
I think he's standing in front of the question.
Okay, shall I give you the mic?
Yeah. There are two mics here.
And I am a maths lover. I love maths a lot, and I heard different definitions of mathematics in different books. And what is your definition for the term mathematics?
See, this is what I told you. Right? I'm used to keep throwing problems at me. Okay, yeah, I don't know. I don't have, in terms of, I in fact teach a course called Nature of Mathematics right now with undergraduate students, and where we look at these questions. So one thing is that mathematics is what mathematicians do. Right? This sounds very crazy. Who are mathematicians? They do mathematics. And what is math? Well, it's like poetry, right? Poetry is what poets write. Right? You can say it's with it should have meter, it should have. But you know poems which don't have all that, no rhyming, nothing, but it's a good poem. So somewhere we understand what that is, right? So mathematics, if anything, it is so. So various great people have asked these questions, and there is one that I like. This is by one great teacher called Halmos, great mathematician and a teacher. So when he talks about what is mathematics, he raises this question: what is mathematics about? Is it about theorems, like fundamental theorem of arithmetic? Is it about definitions? There is something called Menger's definition of dimension, one of the most beautiful books. Is it like about definitions? Is it about proofs? Gödel has this beautiful proof. And he goes on asking. And then he says that all of this is true. Mathematics is about beautiful theorems, beautiful techniques, beautiful definitions, proofs, theorems, all of it. But in a sense, that all of this is part of one thing, which is problem solving. He says the raison d'etre of a mathematician, mathematician exists to solve problems. So if there is one spirit of mathematics, it is in problem solving. So I think I would say, I don't know how to define what you asked. I would say if mathematics is about something, it is about problem solving. It is about, and what is problem solving now? You remember the problem I said? There are 6 towns in flatland. It's a formal problem. Somebody poses a problem. Or it could be like in the case of the tent, where it has come from some need. Tomorrow you need to do something and you want to. But some problem. One important thing that I would like to tell students especially is problem solving is not equal to end of chapter exercises. Right? End of chapter exercises are very important, but they are for a particular purpose. Every chapter at the end has some exercises to do. So you would solve problems. That is not what we mean by problem solving. That's important. But general problem solving, looking at problems, most importantly, a good problem is one when you look at it, you don't know what the answer is. If you already know what the answer is and you know how to solve it, it's not problem solving, right? How do I get from here to Coimbatore? Well, it's a problem, but it's not a particularly interesting problem. There are, particular ways of getting there, right? So when you look at it, or on the, that's why I use the word exploration. When you don't know, you may know a goal, but you don't know path to it. You have to do some trekking, right? You have to do some on the way, right? So, and good problems are those where when you solve, 100 questions immediately come up, more and more. So the problem doesn't end there. You have new questions coming up, and so on. So I would say the spirit of problem solving is at the heart of mathematics. With Hermos. Yeah. Other.
And that could be in any field.
Well, there is at least mathematical problem solving in a particular in that sense. So in some sense, what he's trying to say is that all definitions that you come up with are in the process of trying to solve problems. All theories that you build are in the process of trying to solve problems. That is Hermos's view. Other questions, comments? Yeah. Why don't you mention your name and school as well? Introduce yourself.
Good evening, sir. My name is Gada and I'm coming from Thrissur. I'm always curious to know about the origin of the universe. So can you please explain the
I wish I
the
knew.
origin of the universe?
I wish I knew. I don't know enough to talk about it. Probably there are other people here who can talk about this. Cosmology is not something that I understand very well, but it's the most intriguing question, right? About, well, we read about the Big Bang, and this is a theory, and that seems to be the most convincing theory as of date, and about how the universe began with the singularity, everything. That's all I know. I'm sorry, I can't tell you more, but yes, but one of the most important questions. Yeah. Well, closely related is origin of life. Well, origin of universe, probably we have much better answers. I don't think we have as good answers for the origin of life. More. There is one there.
Good afternoon, sir. I'm Missy and I'm from Kottayam. So I have been having this question in my mind for a few years. So according to you, is there a limit to mathematics? Will there be a point that there will be nothing left to discover in mathematics?
Well, I mean, it's a kind of, the easy answer is no. But then if you ask why, it's very hard to justify. So the point is that, is there a, I mean, he was in fact asking questions. I mean, when he introduced me, he said, this guy works in logic. What research can you do in logic? Right? So, especially mathematical logic. Right? It's actually questions of this kind that you are worried about. At least not in the general term that you say. But, okay, let me answer it this way. That suppose I say that there is no limit to mathematics, right? It's a matter of exploring more and more things. How do I prove it? How do I prove it? Right? Because that means what? Okay, I'm talking about life, universe. I don't know whatever I'm talking about. Maybe geometry, let me say. Right? Maybe it's a simpler thing to say that. Is there a limit to geometry? Okay, then I say, okay, geometric reasoning is about certain particular things. It's about reasoning about certain objects, which you call geometric objects, and I have certain postulates, axioms, Euclid's sort of thing, and then whatever I discover using that. Now, one thing I can then say is that if I keep on changing the postulates, right, or axioms, assumptions, maybe I will get newer and newer mathematics. But then one can ask, okay, but then is there a limit to those? Right? It's not easy to prove, right? So in that sense, I would say there is an obvious answer to what you are asking, which is that no, there is no limit, because at every time that you know something, there is always something that you don't know. But to prove that every time you know something, there is always something that you don't know is not easy. And to me, okay, unless I can set it up formally and try to prove or at least show that I can prove it. Yes. So it's more to do with limits of knowability, right? Is there a limit to know, knowledge, and knowledge of a particular kind, mathematical knowledge that you are talking about, and then you can even particularize it to geometric or algebraic, like it, etc., etc. You can ask such questions. Not easy to answer. That's what I would say. But in a working definition, in the spirit of problem solving that he was talking about, I would say it's clear that there is no limit, because there are always newer and newer problems that come, but without proof. Yeah.
Now my last question, because in the interest of time, we'll push people.
Sure.
In your life, which question make you more panic? In your life, which question make you more panic? How do you overcome it?
Oh my God. What questions panic you more? That is difficult. I would say that those are mostly to do with survival, right? I mean, I remember, once when we were going in the Himalayas and there is a landslide, okay, right? One heavy boulder falling down, right? As it turned out, that the boulder fell ahead and we were spared, but it could have fallen on, our jeep that we were going. The moment of panic of that kind is the deepest, in my opinion, right? When you're fearing for your life, right? And it all happens in the moment. So I would say that. But maybe in the spirit of what you're asking about solving, what are the hardest problems that you solve? Getting 2 children ready in time, when they are in the morning for school bus is an extremely hard problem. So, sorry, yes, you're asking in life, right? This is what I want to say also, because life throws you problems that are not formal problems, right? Not abstract problems, right? And there are different levels of difficulty. And what are hard problems? How do I even think of hard problems? Thanks to I learned, my training is in theoretical computer science. That actually teaches you to think about problems, what are hard problems, easy problems, and so on. So you can do, so you can actually think about these things and reason about it. But I would say panic is not about this. Panic is not about intellectual pain. Those are very momentary things. As I said, all this gray hair, right? If anything else that gray hair gets you is that, don't worry, right? Wait. Take a few deep breaths, drink some water, right? After a while, calmly, you'll get something. You may not do the best, but you will do something. You make progress at the time, right? You start thinking about it, you realize that there's something that you can do, like that particular problem, right? Something, some pattern, comes to you. There are times when you're creative, you do things very quickly, and there are times when you run dry, nothing happens. But then you can read. One of the great things is that you can read, learn. After a while, you come back to it, suddenly it clicks. Right? No problem. So you learn. I don't know the answer to what you're saying, but what I'm saying is that with time, you learn a lot of techniques around it, ways of handling. Right? This is not the end of the world. Right? If a problem I can't solve today, no big deal. Tomorrow, wait it out. But in the meanwhile, read and learn and so on. Right? So I would say that. Thank you.
Thank you, sir. It was a wonderful session on explorations in science and mathematics. As a token of our love, we would like to present a memento to our chief guest. I request Dr. Anand to present him the memento.
Thank you.
Now, it's time to thank the people who have helped us in organizing this inaugural session. We now invite Dr. Bibu, Assistant Professor, Department of Physics, and the coordinator of Crystal and Science Quest residential camps to deliver the vote of thanks.
Hi all. It's a bit odd to deliver a vote of thanks when the camp is beginning. However, it is worth acknowledging all the effort of the people and who, that has come in to arrange this session. So I have actually written down unless I forget anyone. So first and foremost, a big thank you to our little friends, younger friends who have enthusiastically applied to the both the camps, part of the Crystal and Quest. And special thanks to their parents to encourage them to apply and to take them here and be a part of this inaugural function. Thanks a lot. Our heartfelt thanks to Professor Ramanujam for the wonderful inaugural lecture. We learned a lot. These two camps are funded by separate entities. Crystal is funded by KSC STE and Science Quest is amply supported by an endowment fund created by Professor Bhalsa's family and friends. So thanks a lot for that. We are happy to have Leela Madam, Mrs. Sundaraman and Professor Sundaraman here among us. Thank you so much for taking out times to be here. Thanks a lot. And thank you, Dr. Neetu, for all the effort that has come in for this inaugural function. Thank you so much, Dr. Anand, to give the welcome address. IIT Palakkad has supported us in a big way with transportation, accommodation, and all the infrastructure. So thank you, thanks so much for that. The inaugural function is made possible because of great efforts by volunteers and my colleagues. So thanks a lot. I hope the same level of involvement happens throughout the camp. Thanks the CFET team for the audiovisual support. And finally, to my young friends, I hope you will have a great time in the camp. Have fun with science and mathematics. And most importantly, as Professor Ramanujam said, explore. Thanks a lot. So just one quick thing before you leave, Dr. Roshita will give you some instruction. Yeah, just stay back for that. Yeah. So only the students can stay back.
Students and parents can stay here.
Yes.
എത്ര പേരുണ്ട് ഇതിൽ ക്രിസ്റ്റൽ ജൂനിയർ സീനിയർ ബാച്ച് എന്ത് പറ്റിയോ ആവേശമൊന്നും കാണുന്നില്ലല്ലോ സയൻസ് ക്വസ്റ്റുകാരുടെ ഓ നിങ്ങൾ ഇപ്പോഴേ രണ്ട് ഗ്രൂപ്പാണോ ഡോണ്ട് വറി ഈ പ്രോഗ്രാം കഴിയുമ്പോഴേക്കും നിങ്ങൾ എല്ലാവരും മിക്സ് ആയിക്കോളൂ ഓക്കെ സോ കുറച്ച് ഇൻസ്ട്രക്ഷൻസ് നമുക്ക് തരാനുണ്ട് നിങ്ങളുടെ ഷെഡ്യൂള് ഇപ്പം ഇവിടെ വളണ്ടിയേഴ്സ് സ്റ്റുഡൻസിന് ഷെയർ ചെയ്യും അത് നിങ്ങൾ കയ്യിൽ വെക്കുക ഓരോ ദിവസത്തെ പ്രോഗ്രാം അതിൽ കൊടുത്തിട്ടുണ്ട് എവിടെയാണ് വെന്യൂ എന്നുള്ളതും കൊടുത്തിട്ടുണ്ട് ഓക്കെ അപ്പൊ എല്ലാ ഹോസ്റ്റലുകളിലും എല്ലാ ദിവസവും നിങ്ങൾക്ക് വോളണ്ടിയേഴ്സ് ഉണ്ടായിരിക്കും അവരെ ഫോളോ ചെയ്തിട്ട് കറക്റ്റ് ടൈമിന് ഇവിടേക്ക് വരിക ഇപ്പൊ രാവിലെ നിങ്ങളെ വീട്ടിലെ കുറച്ച് എഴുന്നേൽക്കാൻ വൈകുന്ന കൂട്ടത്തിലാണെങ്കിൽ നിങ്ങളുടെ നേരത്തെ എഴുന്നേൽക്കുന്ന ശീലമുള്ളവർ പോയിട്ട് അവരെ ഉണക്കുക അപ്പൊ നിങ്ങളുടെ അടുത്തുള്ള റൂമിൽ ഓക്കെ പിന്നെ വളണ്ടിയേഴ്സ് ചിലപ്പോ ഉണ്ടാവും അപ്പം മിക്കവാറും അവര് വന്ന് ഉണർത്തും അങ്ങനെ ഒരു സാഹചര്യം നിങ്ങൾ ഉണ്ടാക്കി